What is a logarithm? So in the last video we looked at using logarithms to solve some exponential equations. We're going to have a quick recap of that in a second to solve this slightly trickier exponential equation. And we're also going to use that same idea to actually solve a log equation here. First of all, with these particular examples, the first thing to note is this example here. The idea of this is a square root with an x inside it. Now to solve an equation, we're going to get x on its own. The problem is x is inside of a square root. Now one thing we would not do is we would not take the square root across right now and make that a squared. What we would do first is we would get rid of this minus 7, we'd get rid of this 3 until it's just the square root left, and finally then we'd take the square root across and make it a square. So let's have a quick look at what it looks like. We would write 3 root x minus 1 equals minus 1 plus 7 gives us 3 root x minus 1 equals 6. Then we would write root x minus 1 equals 6 divided by 3. Take that across, divide, gives us 2. And now to get rid of this root, we'd finally take it across. It'd become the opposite of a square root, a square. So we get x minus 1 equals 2 squared. 2 squared is 4, so we get x equals 4 plus 1, x equals 5. With that out of the way, let's solve these. So we can't take this exponential base 4 across right now. First thing we need to do is we're going to take this 16 across. So we get 4 to the power of 2x minus 1 equals 0 plus 16 is 16. And now that everything on this side is inside this exponential, we can grab this exponential, this 4, take it across, and the opposite of an exponential with a base a is a log to the base a. The opposite of an exponential with a base 4 is a log to the base 4. Now this power drops down, 2x minus 1, and this becomes log to the base 4 of 16. Now, opposite of an exponential is a log. First thing is, if we tap this on a calculator, log to the base 4 is 16. Often it's been given as a decimal. This time will actually give us the answer 2. So we get 2x minus 1 equals 2. So 2x is equal to 2 plus 1. So x is equal to, well, 2 plus 1 is 3, divided by 2, well, that just leaves us with 3 over 2, and that's our answer. Let's have a look at this log equation now. We're going to use a similar process. Remember I said that an exponential to the base 4, when we apply change sign, becomes a log to the base 4. Well, we actually want to get the x on its own here. So again, first of all, not everything here is inside of a log. So first thing is we're going to take that 2 across. We're going to get log to the base 3 of x equals 6. Take away 2, which is 4. And now that this whole side is kind of enveloped in a log, we can now grab this log to the base 3. So what does a log to the base 3 become? Well, it becomes the opposite, which is an exponential base 3. Now careful what goes here. The temptation is to put 4 here and move the 3 up as a power. The 3 is a base here of a log. It will become the base of the exponential. And that 4 actually gets pushed up here, and we're going to get the answer x equals 3 to the power of 4. So it's 3, 9, 27, 81. So the question here is, what is a log? Why did log to the base 4 of 16 in our calculator give us 2? Let's also have a think about this answer here. If I use a cover-up method and just cover up log to the base 3 of x, I get something plus 2 is 6. Well, that thing here must clearly be 4. So y is log to the base 3 of 81, 4. That's what we're going to answer just now. Okay, so what is a calculator actually doing when we ask it to calculate log to the base something of something? Well, the way to read log to the base a of n is a to what power is n. So, what is log to the base 4 of 16 without a calculator? So we ask ourselves 4 to the power of what is 16? 4 to the power of what is 16? And the answer is 4 squared is 16. In other words, 4 to the power of 2. So the answer is 2. Let's go here. Log to the base 2 of 8. 2 to the power of what is 8? The answer is going to be 2 cubed is 8. The answer is 3. Log to the base 10 of what is 1,000? The answer is, again, 3. Log to the base 7 of what is 7? Now, 7 to the power of 1 will give us 7, so the answer is 1. Last two, slightly trickier. Log to the base 3 of 1 over 9. 3 to the power of what is 1 over 9? Well, we can see there's some kind of squared link going on here. 3, and we've got a 9 down there. So if it had been log to the base 3 of 9, we would be saying the answer is 2. However, we've ended up with 1 over 9. So what we've ended up with is 1 over 3 squared. And the power which will give that is minus 2. So that means 1 over 3 squared, 1 over 9. And the last one here, 12 to the power of what equals 1. The only way we're going to get that is 12 to the power of 0. So the answer is power of 0. So that leads us to some general rules. First one is log to the base a of 1 is always going to be 0. A to the power of 0 is what's going to give us 1. So any log 1 with any base will always be 0. The second one is log to the base a of itself will always be 1. So if you had log to the base 7 of 7, log to the base 23 of 23, that's always going to give you 1. And we get this general pattern here. Let's say we've got a base of a, and then up here is whatever a is squared. So for example, 4, here would be 16, 5, here will be 25. That's always going to give us the answer 2. So if we could write it like this, then the answer is going to be that number there. The final thing to note is that you can't have a log of a number which is 0 or less. So in other words, if we're taking the log of x, then x has to be greater than 0. Otherwise, our calculator will say math error. So next of all, what can we do with logs? Well, just like there's laws of indices, x to the power of a times by x to the power of b, well, you would then add those powers and you'd get x to the power of a plus b. There are some laws for logs too. So I'm going to write down the 3 laws that you need, and the proofs for these I'm going to post a link to for you to have a look at if you wish and ask me some questions on if you wish. However, we don't need to know the proofs, so I'm just going to give you these laws now. The first of all is if you have a log to the base of a or n or anything of x, and you add it to a log to the base a, it must be the same base there, of y, then the result you get is actually log to the base a of x times y. So when you add together 2 logs, they become multiplied inside of a log. These are called the arguments here. So x and y become multiplied inside the same log. And in a similar way, if you have log to the base a of x, take away log to the base a of y, then what you end up with is log to the base a of x divided by or over y, which will come out like that. And the final one is if you have n times by log to the base a of x, so if you multiply a log by any number or any letter, then what you get is log to the base a of x to the power of n. So when you multiply a log, it can actually be then moved up and put as a power of the argument there. Okay, so what we're going to now do is focus on using these 3 laws or these 3 rules of logs. So let's try and evaluate these 3 log expressions using my 3 log laws here. So I'm going to go for 3 and then another 3, and there are plenty more examples on the worksheet which will be attached. So we've got log to the base 10 of 2 plus log to the base 10 of 500. So when I add 2 logs, if they've both got the same base, that's important. It means I can multiply them together. So 2 times 500, this will become log to the base 10 of 1000. 2 times 500. And then I ask myself, 10 to the power of what is 1000? And the answer is 3. Next question. Log to the base 4 of 80, take away log to the base 4 of 5. Same log, so I can apply my log rules. So take away means I'm going to do x over y, I'm going to do 80 divided by 5. So this becomes log to the base 4 of 80 divided by 5, which is log to the base 4 of 16. I'm just going to squeeze my answer on here. That's the same as 4 to the power of what is 16. The answer is 2. And finally here, I've got a log to the base 6. I'm taking away a log and I'm adding a log. So all my positive logs, my additional positive logs, are going to be multiplying, and all my negative logs, which is just this one here, are going to be dividing. So this is going to combine to become log to the base 6 of 8 times 9 times the positive ones together, and divide by the negative 1. So this will become log to the base 6 of 8 9s are 72, divided by 2 is 36, and that gives us a final answer, 6 to the power of what of 36, and we get the answer 2. So I'm actually going to look at 2 more examples. Here they are, and you'll see that we're now including this third log law. Now the first thing is I can't start to put together these logs until I've got everything as a plain log, in other words, no coefficients in front of it. So first thing I'm going to do is I'm going to take this 2 log to the base 4 of 2, and I'm going to take this 2 and I'm going to put it up here as a power. So this becomes log to the base 4 of 2 squared, and the rest I'm going to leave the same for a second. Oh, didn't notice there's 2 here, so what we're going to do here is also put that 2 in here. Log to the base 4 of 4, grab that 2, that goes up here as well. And now we're going to put them all together, they're all just logs. Now I've got 1 positive log and 2 negative logs, 2 takeaways. So this one is going to be multiplying, or at the top, and I'm going to be dividing by both of these. So I'm going to have log to the base 4 of, so the only thing that's going to be on top is this 2 squared, well that's just 4. And underneath I'm going to have a quarter, and I'm going to also be dividing, so I'm also dividing down here by 4 squared, well that's 16. And this gives me log to the base 4 of, well, a quarter of 16 is 4, 4 divided by 4 is 1, so I get log to the base 4 of 1. And any log to the base, so I get log to the base 4 of 1, and any log of 1 with any base, the answer is 0. So have a think about that. 4 to the power of what is 1, the answer must be 0. Final one here, we're going to do the same thing. We're going to grab these coefficients, put them inside as powers, and then combine these logs. So I get log to the base 2 of 16 to the power of half, take away log to the base 2 of 8 to the power third. Now I'm going to need to know what fractional powers are. So 16 to the power of half, well that's just root 16, and root 16 is 4. So this becomes log to the base 2 of the square root of 16, 4. And what is 8 to the third? Well, a third power is a cubic power, cube root, I should say. So log to the base 2 is the cube root of 8, and that is also 2. So we're going to combine those now. We get log to the base 2 of, now this is a takeaway, so the 4 is going to go on top. I'm going to divide by the 2 using my second law of logs. So I get log to the base log to the base 2 of 2, and that gives me 2 to the base. So that gives me log to the base 2 of 2. So 2 to the power of what is 2, the answer must be 1. Remember that rule, log to the base a of a, whenever these two numbers are the same, the answer is going to be 1. So we're going to go into log equations in just a moment, but first of all, we're going to look at how some relationships which seemingly are all about logs can actually be broken down into a much more simple relationship between x and y in this case. And the way we're going to do that is use our log rules on the right hand side, and then I'm going to show you a trick at the end. So I'm going to leave the left hand side as log to the base a of y here. Now we're going to bring this 3 up here. Now why are we doing that? Well, that's because once these are both logs with no coefficients in front, I can use my laws of logs to combine them. So log to the base a of y is equal to log to the base a of 4 times x cubed, 4x cubed. And here's a final trick. If I was to say x squared is equal to 9 squared, and I was to ask what x is, well, if x squared is equal to 9 squared, well then x and 9 must be the same thing. And the same is true here. If the log of y is equal to the log of 4x cubed, then y and 4x cubed must be equal. So what I can actually do here, if you like, is cancel out the logs. Leaves me with actually a nice and simple relationship. There's actually a cubic relationship between y and x instead of this log relationship that I saw before. So let's try one more example of this. So I've got another relationship between y and x, again logs involved, and I want to see if I can break it down into something more simple. So if I can get logs on both sides, well that's nice because I can just cancel and see what I'm left with. Well, first thing is I'm going to need to move this free from here, and using this rule of logs, it's going to go as a cubic up here. So log to the base 2 of y cubed. Now my problem is, how do I bring this free to come and join in with a log to the base 2 of x minus 1? Well, I'm going to need to write it as a log to the base 2. So I'm going to leave this one here for a second. And I want to write plus 3 as log to the base 2 of something. Now, if I write 8 there, then hopefully we can see that 2 to the power of 8, that would actually be 3. So those two things are the same, so I can do that. And now I can bring these together. Log to the base 2 of y cubed is equal to log to the base 2 of 8 times by x minus 1. And finally, I can cancel log here, they cancel out, and leave me with y cubed equals 8 brackets x minus 1. Final answer there.